So I'm just going to go with it. So yeah, so today I want to talk about what we're doing here at Khan Academy because I think it's pretty interesting. So first, what is Khan Academy? Khan Academy is a nonprofit, if you haven't heard of it, that our mission is to provide a free world-class education to anyone everywhere. And we do that through a lot of different ways. We have a lot of people who are really interested in trying to make the world a better place. And this is one of the ways that we feel like we can do that by actually helping other people to get a high quality education no matter where they are in the world. And as part of that mission, one of the things that I'm really proud about is that we learned a long time ago that having a diverse workforce helps us to be able to actually to do better, to think better, and to be more clear in our to make better solutions that fit people better. And as a result of that, I really love it. And I love the fact that my coworkers are some of the kindest people that I've ever had the fortune to work with. And so I wanted to do this talk as a kind of as a love letter to basically say how much I love working for Khan Academy and some of the great stuff that we're doing. So the stuff that I'm going to present today is not my work, but is the work of some of my coworkers. And I wanted to basically just say how cool they were in having figured this out. So, um, so, um, so again, Khan Academy, we're trying to fulfill that mission, and how we end up implementing it is actually, I think, an interesting story. So I actually have been working there for a year and a half, and I worked at a lot of other places before that. And so I'm a senior engineer at Khan Academy. Mostly I do back-end stuff here, but I've done front-end at other places and DevOps at other places. So I already went ahead and talked about this, but so I do love what we do together. And I wanted to tell you about how we started out. Originally, Khan Academy got in on GCP App Engine when it was still in beta. And we built a Python 2 monolith on top of that. And I think that was actually a really excellent decision. And it ended up being a gamble that really paid off for us. We still love App Engine, and we plan to continue to do so. One of the things that was great about it is that when the pandemic hit and we had just a huge, normally we have an exponential curve of growth over our timeline, but we just had a giant a surge of people who were using Khan Academy, and it really didn't have any problems in production as a result of that. There were a few little things that needed to be tweaked here and there, but I think what's pretty amazing is that because we run on GCP and because we don't let ourselves get entangled in other things that don't provide value, and we just offload that to GCP App Engine, we are able to actually focus our organization more on providing value to the people who we really want to serve. The thing that we do need to change is that we actually have found that Python 2, first of all, it's end of life. Secondly, we've grown as an organization engineering-wise, and our code has also grown in complexity, and it's becoming difficult for us to maintain the level of, as our monolith has grown and grown and grown. So we're actually going to use multiple Go services, and we are splitting things up into 27 different Go services. These aren't necessarily incredibly microservices, but they do break things up. And we're using GraphQL in between them. And I want to talk about how that has been a tremendous boon to us. So when we picked that Python 2, we ended up picking Go, and it actually, we found that our individual Go services are much faster. There's a really rich ecosystem, so we're not building everything from scratch. We find it very simple and productive. The other thing that I really want to say about Go is that everybody talks about how fast it is, but it's maintaining somebody else's code is a real pleasure in Golang, which I don't know is necessarily the case for other languages. I've maintained a lot of legacy systems in a lot of different languages, and I really love different programming languages. They're fun to geek out about and to be able to play with. But the problem is that I love writing my own code in those languages. I don't necessarily like maintaining somebody else's code in those languages. Especially as an application grows over time and teams come and go, you have a language where you have multiple different paradigms and shifts. Sometimes it's actually pretty complicated to try to get into the mindset of whatever this piece versus that piece look like. Where when I'm maintaining someone's Go code, it looks pretty much just like my Go code. And I think that that's a real testament to the simplicity of the language itself and the elegance with which it was designed. So when we were picking which platform we should run on, we again chose App Engine, and we helped to avoid undifferentiated heavy lifting. It scaled great, like I said, during COVID-19. The other thing I want to say is it is so reliable to be on GCP with App Engine. We have an all volunteer PagerDuty. It's opt-in. I've been at places where it seems like, oh, we're cloud scale, but people are waking up in the middle of the night all of the time just to keep turning some crank to keep the system running and intervening to keep it reliable. And that's not our experience at all. We've had less than one after hours PagerDuty a month, and a lot of those were false alarms. But, we thought, we could really cut those down. But, it's good to stay in practice. And I feel like that is so different than the industry standard that it's worth trumpeting, because I think a lot of people end up picking other solutions, and they end up actually having a lot of sleepless nights as a result, where I sleep incredibly soundly knowing that everything's on App Engine. So thank you. The other choice that we had to pick was whether we should stick with a monolith or whether we should switch to services. And it's a difficult choice because we're changing things a lot by switching from some other things. So we chose to switch things to services because really it actually helped us in a human scaling way to be able to have some sort of encapsulation that this was a team's domain and that they could actually be able to really go deep with that. We also found that having independent deployability had a number of advantages to speeding up our overall organization's productivity. We also found that it gave us pretty granular cost tracking that was aligned to specific values. So, for instance, a particular team might have 3 or 4 services that they were involved in, but we could tell that a particular business value that we were trying to provide, we could see how expensive that was versus how much value it was providing for those students or teachers or districts. And we could actually tell, oh, you know what? This service right here it's really very expensive and it's not really adding a lot of value. Maybe we should rethink this. Or this particular service is really cheap to operate and it is actually super useful. And so we should invest in that and grow that. And that just kind of falls out from using services, where when you have a monolith, it's possible with profiling to get that same sort of information, but it doesn't just magically fall out in the same way. And so we found that to actually be pretty useful. The communication between different services is also an open question that we had to decide. And so we had great success on our front end with using React with GraphQL. And we decided that since App Engine did not support HTTP2 or gRPC yet, feel free to put that in our Christmas wish list. the thing that we really liked about GraphQL was it provided a ubiquitous language across both JavaScript and Go, and that we could actually write things that were schema driven and code generated. And that helped us to not have to deal with a lot of contract testing that we thought would be brittle. It helped us to be able to have our backend engineers being able to really be able to understand with very little impedance exactly what the front end engineers wanted to deliver. And it's helped us as an organization in a number of other ways that I'm going to go into. So we also had to decide, okay, so if we're going to divide into services, how should we divide those things up? And so this is like a brief summary of some of the 27 services. And we decided that our basic architecture, we're fronted by Fastly. They're awesome, by the way. We use Apollo's GraphQL gateway to provide federated GraphQL queries and mutations across our different services. And then our different services are broken up, lined up across business value or domain. And that's worked out pretty well for us. So one of the things that we've learned, some things that we've learned as we've transitioned is that we made a simple test-driven development command line app to help engineers who were new to Go. And we basically did it the way that Khan Academy works, where we have, all the tests were already written and people tried to just make the test pass. And there were comments with individual code snippets or hints that as you got further along, usually the first hint is just a basic, hey, maybe think about this, looking at this documentation. And then the last hint is always like, here's the complete solution, so you can just paste it in if you need to. And that was actually a pretty gentle way to introduce people to it. It's also a testament to Go that it had a pretty straightforward syntax. After that, we invited people to use Learn Go with Tess. And we had the whole organization trained by Arden Labs, and Bill Kennedy was awesome. And then we've actually developed an internal cookbook so that whenever there was a problem that we've encountered, especially if you see it more than once, we tried to actually make, here's how to solve a common problem. Like if you're like a recipe, for instance, if this is the kind of Python that you're trying to port, here is how we have done it in Go in the past, and use that as a reference. We've also have an onboarding repository that we've been contributing to and helping other people in other meetups be able to look with. So having trained our engineers, we wanted to actually then focus on how to safely transition applications. And we didn't want to do a big bang rewrite. We wanted to be able to gradually do things in a very safe and incremental way. And one of the ways that we chose to do that was to use a form of traffic shadowing, where requests will actually go to both Python and to Go. And we will compare them, but we'll only use the response from Python until we feel confident that Go is ready. And we can always switch. And when we switch, we can always switch back. This technique, I think, was first popular with GitHub's scientists. And there's been other libraries and other frameworks where this has been implemented. But as far as I'm aware, this is the first time that I think an organization has used GraphQL for this kind of side-by-side testing, and specifically GraphQL federation. So I wanted to talk about it because I think it's actually kind of cool, and it's been so seamless and so wonderful that I think it's worth other organizations looking at it as well. So the way that we start out is we have all the code is written in the Python monolith, and then we develop in a Go service things that will actually fulfill the same contract, the same that's defined in GraphQL. Then we switch things to Python being primary, where Go is secondary. And the responses from Go are compared to Python, but the end user only sees the Python responses. And when we feel like we're ready, we can switch to have Go be primary. And so now the end user is seeing the Go served responses, but Python's still secondary, and we're still comparing those. And then we can transition to having it just be run by Go only. So when you're inside of the monolith, this is kind of how a request would look like. It goes from the front end, through the GraphQL gateway, and then it would go to Python. We then develop the Go service, and we then have Python be primary, but we have Go be secondary. We then have Go primary, and Python is now secondary until we transition it to be Go only, and we delete the Python code. So now it's code time. So the thing is that when you have a GraphQL schema, it looks a lot like this. And so this is an example field that we actually really had to port. And what would happen is we started out, this is the GraphQL schema before when it was just in the Python. And we started to actually build things in Go. Now, the problem is that when you have a federated schema, you can't have two things that define the same field exactly. Otherwise, that's an error for federation. So we have a directive called migrate that basically will hide this field from the full schema, and only the gateway will really know that it even exists, so that other services, they don't need to know that there's two things that are implementing this. It's just a gateway implementation detail. And we set the state there as manual, so that it would have to be that somebody would manually have to opt in to getting this from the Go service. And then we switch that to be side-by-side, which indicates that now we want to actually have requests going to Python, but that that they should actually be served and compared from both of those. When you look at the side-by-side differences, you might see that there's a slight difference. Maybe the time zone is wrong or some other kind of thing. This one I just kind of pretend I made it a bug on purpose so that it would actually be more interesting to look at. But then you can also get a number of different reports by different services and different file paths, and how those different operations might have had over millions of users or millions of requests that happened in the last hour or something like that. And you can get a full more detailed report that talks about that. And some of those changes might actually, you look at them and you're like, oh, that thing is actually not sorted properly because it was an unsorted list in both of those. And so, yeah, okay, I see why that is the case. So I guess we'll sort both of them temporarily, and then we'll try it again. And we're confident, okay, now we can go back. And then maybe later we can switch it off of being sorted for better performance, because we never really cared that it was sorted, so. We also see all these different metrics that they're watching. This is just one. We have like lots of different SRE dashboards that show us different fine-grained details, so that we can find like, oh, there's occasional errors or other sorts of things that are happening. So when we're all done and we think, okay, this is actually good to go, we're set, we can change that in the schema so that it's actually fully migrated. And what this will do is now Go is serving, and actually Python is going to be ignored. So once that's actually, we're fully secure with that, we can actually delete the Python code and delete the actual migration directive and just have it be served from Go. So again, this is, you start out in a monolith, you develop in a Go service, then you actually have Python be primary where Go is secondary, and then you have Go primary and Python is secondary until you transition to Go only. And this is a really safe way to get through this with large-scale migrations, building it in the air while millions of users are using it. So, but this begs the question, this is great for queries, but for mutations, how do you deal with that? If you're altering persistent data, side-by testing is not really such a great idea. Like if the mutation is that we want to increase some student's skill by 1, well, if you do that twice, you'll end up with, oh, the skill increased by 2. So we need a safe and gradual traffic shift. And ideally, that would be internal traffic first. So if you look at a traditional deployment, the main super popular way that started out was blue-green deployments. And or I think Netflix calls them red-black because it's logo compatible. But what you do is you release a new version alongside the old version, and then you switch. So that all those requests, they start out going with the first one. And this is an example of like a Grafana dashboard that would show that traffic. And you just flip a switch, and now everybody's getting it from the other one. So side-by-side traffic, the traffic looks more like this. You release a new version alongside the old version, but the incoming traffic is mirrored to the new version and doesn't impact the response. You're just comparing them and looking at errors and performance and all that kind of stuff. In a canary, you're able to release a new version to a subset of all users and then proceed to a full rollout so you start out with only a few users and we start that out using our handy different GraphQL canary. And you may, if you're a fan of ornithology, you may have, know of the different species of canaries, such as the great North American GraphQL canary, seen here with its hexagonal plumage. And so the thing with what we use with those canaries is that we have a selective release of features to a random subset of requests for testing purposes. And we gradually increase traffic from 0 to 100%. This can be either manually done slowly, or we can do it fully automated if we feel confident that just monitoring the metrics that we have tells the whole story. So if you have more than 0%, that means that all internal users will get the canary treatment. So they'll get the responses from that canary, where we might have most of our actual users still getting the results from the original Python monolith. So this is a nice way where what we'll do is we'll change the schema so that when we have the Python code, we'll have the beginning of the Go code, and we'll have a migration there when the state will be canary. And we pick a color because canaries are colorful, and we like to be able to have only a few experiments going on at the same time, so that you don't get sort of a mix of canary colors that are sort of obscuring the data. At the same time, we don't want to necessarily, it uses an exponentially larger amount of memory to have to try to have a whole lot of different canaries going on for the same fields. And so we want to try to limit that as much as possible. And so then what happens next is we will switch it so that after we have either manually or automated switched all the way from 0 to 100% of the traffic is being handled by the Go code, we will then actually be able to delete the Python code and delete the migration directive from the Go code. So the upshot of this is that engineers are happy and productive using Go code, where before they had a lot more trouble trying to figure out what was happening in the Python code. Our efficiency has gone up quite a bit, and our costs are bending down. What's next for us is that we have 65% of our production traffic is served by Go. We are open source by default. So if there's a solution that we have that is useful to other people that we can make independent enough from our own bespoke stuff, we would go ahead and open source it. And we're sharing our onboarding process to try to be able to help other people to be able to take advantage of the good fortune that we've had in investing in both Go and in GCP and in GraphQL. So if you're interested, feel free to reach out. We are indeed hiring, and I am open to any questions.